Object-oriented programming is a programming paradigm that is based on the concept of objects. Objects can contain data, which is in the form of attributes, and code, which is in the form of procedures or methods. Programs that use the object-oriented programming paradigm are creating objects that interact with one another. Object-oriented programming languages are diverse, with the most popular ones being class-based, which means that objects are instances of classes. Popular object-oriented programming languages include C#, C++, Python, PHP, Ruby, JavaScript, and Java. In this video, we will delve deeper into Java's collections framework. More often than not, software systems do not store entities as individual items. Instead, they are stored as various groups of entities. One way to do this in Java is by using collections. Collections, also known as containers, are classes that store groups of individual objects. Now you may be thinking, an array has the similar function as a collection in such a way that arrays also store groups of individual objects. So what makes collections different from arrays? To put it simply, arrays are fixed in size, which means that its size won't be altered once the array has been declared. On the other hand, collections are dynamic in size, which means that its size can be altered based on the program's requirement. A more comprehensive comparison between arrays and collections is shown in this table. Now that we know the differences between arrays and collections, let us proceed with our main topic, the Java Collections Framework. The Java platform provides a collections framework, which is a set of classes and interfaces which provide a ready-made architecture to store and manipulate a group of objects. This diagram is a simplified overview of the collections framework. It shows the interfaces and classes that implement the interfaces. The primary interface of the collections framework is the collection interface, denoted by java.util.collection. There is no direct implementation of this interface. However, it is indirectly implemented through its sub-interfaces, such as list and set. In other words, the list and set interface are extensions of collection. They inherit the methods of collection and add its own unique methods. Another root interface that belongs to the collections framework is the map interface, denoted by java.util.map. Unlike list and set, map is not an extension of the collection interface. This is because maps do not entirely fit into the collection hierarchy for reasons I will explain more in detail later on. To sum it up, the collections framework is a set of interfaces and classes that provide an architecture to store and manipulate groups of objects. The collections framework is composed of interfaces that are extensions of two main root interfaces. We will now discuss some of these interfaces. The list interface is an extension of the collection interface and is the most commonly used type of collection. Lists are general-purpose data structures that provide a way to store a collection of objects in a specific order. In the collections framework, there are two classes that implement the list interface, namely the ArrayList class and the LinkList class. The ArrayList class uses an array to store a collection of objects. However, unlike traditional arrays, ArrayLists can automatically adjust its capacity when we add or remove elements from it. therefore making array lists more flexible. Array lists can be helpful in programs where arrays are manipulated frequently. The linked list class is an implementation of the linked list data structure, a linear data structure where each element is a separate object with a data part and an address part. Each element is known as a node and is linked using pointers and addresses. The set interface is another extension of the collection interface that is based on the mathematical idea of a set. Sets have a feature that restricts the insertion of duplicate elements, and it also does not arrange items in order. The sorted set interface is an extension of the set interface, and it is a special kind of set that allows elements to be stored in a sorted manner. The treeset class implements this interface. The hashset class is a direct implementation of the set interface that uses a hash table to store elements. Hashset allows null values, however, hashset does not maintain the insertion order. Instead, elements are inserted based on their hash code. The map interface is the third interface in the collections framework. Although it is part of the framework, it does not belong to the collection hierarchy. This is because maps store objects in pairs, unlike list and set that store objects individually. The pairs consist of a key and the value. A key is an object that identifies the pair, while a value is an object that is associated with the key. The tree map class is an implementation of the sorted map interface, which is an extension of the map interface. The tree map class provides an efficient means of storing key-value pairs in sorted order. Meanwhile, the hash map class is an implementation of the map interface. Hash maps are similar to hash sets in a way that it also allows null values and does not maintain order. However, since it implements the map interface, elements are stored in a key-value pair.
So now that you guys learned about the intricacies and the concepts behind the Java Collections framework, I will now teach you guys how to code it. First, we'll start with linked list. Before anything else, what you want to do is you want to import the linked list utility package. To do that, you type in import space java.util.linkedlist semicolon. This basically allows us to use the linked list utility package that comes with Java. Next, you want to create your class and your method. To start or initialize your linked list is you want to type in linked list angled bracket, the data type of your choice. For our example, we'll be using integer. The name that you want to put on for your linked list, for our example, list equals new linked list, the same data type as before, integer, and then open and close parenthesis and a semicolon. So now that we've created our linked list, you want to add things into it. To add items or objects into your linked list, you want to use the command .add. So to do that, we do the name of your linked list, list for example, .add, and then the object that you want to add. Reminder, the data type of your object should be the same from when you initialized your linked list. So since I initialized mine as an integer, we're using 1. So the next command that I want to show you guys is the .get command. This command gets the object from a specific index. So to use that, you do list.get and then the index of the object that you're looking for. And then the next command I want to show you is the .remove. The .remove command is used for when you want to remove an object from your linked list, or if you want to remove the object from a specific index. So to do that, you do list.remove and then the index. So that's, for example, 2. And then now let's say you want to add, hey, Future Ila here. Due to some audio issues, I'm going to be dubbing the rest of my explanation for linked list. So to continue off, if you want to add an object at a specific point, we're going to have to use the .add method, but this time we're going to be adding the index before our object that we're going to add. So for example, you want to add 69 at index 2. To do that, you need to do list.add 2 for the index, comma, and then 69. Next is, if you want to replace a specific object, what you want to do is you use .set. So to use that, you do list.set the index of that object that you want to replace. So for example, index 1, and then the new object, let's say 420. The next few commands that I want to show you guys is .get first and .get last. These commands basically get the first item or the first object from your list and the last object from your list. So now I'm going to show you guys how the code runs. As we see here, our first line is 1, 2, 3, 4, 5, which is all the items that we added, all complete. It got printed out. Next, we have our .get index 2 here. It's there. Item at index 2 is 3. And then now we have the .list remove index 2, and then .add 69 at index 2, and .set 420 to index 1. So we see there 69 got added at index 2 and index 1 got replaced with 420. And then the original number at index 2, which was 3, got removed. So now we have 1, 420, 69, 4, and 5 in our linked list. And then now we have our last two lines, which is the get first and get last. As we see here, the first item is 1 and the last item is 5, which is the same. So that's it for our linked list. And next I would then explain to you guys the array list. Now there are other methods which you can use for linked lists, so I'll show them now on screen. That's pretty much about it for linked lists. Next I will explain to you guys about array lists. So now I'm going to discuss about array lists. Now it's basically the same as linked lists, but instead of us importing Java util linked lists, we import array lists. So import space java.util.arraylist, then semicolon, and then we do the same. We create our class and then our method, and then here's our main method, and then to initialize our array list is basically the same. Array list, angled brackets, the data type, the name of your array list equals new array list, angled bracket, data type, open close parenthesis, and semicolon. And then, as I've said in the beginning when I was explaining array lists and linked lists, they're basically the same. The only thing different about them is how they work behind the scenes. So our methods are still the same. So we have add, which we can use to put objects inside our array list, and then we also have our get, and then we also have our remove, and we also have our contains method. Although I did not discuss it when I was explaining about linked lists, you can still use the contains method for linked lists. And basically, the .contains method returns true if it finds the object inside your list. So to use it, you just put the name of your array list .contains and the object you're looking for. So for example, a list .contains and let's say we're looking for 15. And then it's also still the same as linked list. We have our dot clear, which removes everything from the list or all elements from the list. So to do that, you just do a list.clear or name of your array list.clear. And so now here is how this code runs. So as you see, we added 1, 11, 12, 13, 14, 15, all present as we did. And now we have our .get command here, a list.get4, getting the fourth index, getting the fourth index, index 15. The fourth index 15, so that's 0 1 2 3 4 15, that's correct. We're also removing 11, and then we're also removing 11 and then printing the array list again. And as you see, the 11 is gone. All we have now is 12, 13, 14, 15. And now we're checking if it contains if the array list contains 15. Dot contains 15 returns true, and then now we're clearing our array list. A list.clear, and everything is gone as you see there. So that's basically how you use the array list. It's basically the same as linked list, but then I will still show you a couple more methods that you can use for array list. So that's it for lists. Now I will move on to discussing hash set. So same as usual, first thing we must do is we type in import space java.util.hashset semicolon, and then we create our class and our method. Now that we have our class and method, we're gonna initialize our hash set. To do that, we're going to do hash set angled bracket data type. For our example, integer. Name of your hash set. For our example, hset equals new hash set angled bracket data type, closing angled bracket, open and close parentheses, and semicolon. And now that we have our hash set created, we can now add items into our hash set. To add them, we're going to use .add again. So hset.add, since we created our hash set with the data type integer, we're going to be using numbers. So hset.add 21. So repeat that how many times. So for example, we have hset.add 420, 34, 69, 69, and 404. So now that we have our items added, we can now print it out if we wanted to. And if we wanted to see if an item existed inside our hash set, we use again the .contains method, which is again a code or a method that returns true if the object is found inside the set. So we have here hset.contains 69. That will return true if 69 is found in our hash set. Next is something new, I guess. hset.isEmpty. Now the .isEmpty method or code returns true if there are no elements inside the set. If there is even one element in the set, it will return false because it is a boolean method or code. So now we also have to check the size of our set, we have .size and some other codes that I will show you later. So for now, let's see how this code runs. Now do note, because this is a set, there are no duplicate items. So as you see here, there are two hset.add 69. The second 69 will not be added into the set because all items in a set must be unique. Now on another note, because this is a set, there is no particular order. So the order of which we added our items or objects inside the set will not retain. Or if it retains, it will be not everything. So let's run this code. So here, so we added 21 for 420, 34, 269s, and a 404. And as you see here, 34, 420, 404, 21, and 69. And as I said, you cannot have duplicate items, so there's only 169, and the order is not retained. We added 21 first, but now it's in the 4th position. For 22nd, it retained. 34 from 3rd became 1st, 404 from last became 3rd, and 69 is now last. And then for our contains method, the system.out.println hset.contain 69, it should return true. It is true. And now we have hset remove 404, and then we have hset.isEmpty. Now, because we did not, since we only removed 404 and we did not use .clear, there should still be items in our set, and as it is, it returned false because there are items in our set. And now from 5 items, as you see here, 5 items, we used hset.size. There are now 4 objects in the hash set, and we printed out our set again. 34, 420, 21, 69, and 404 is gone. Error 404. So that's basically so this is how you create a hash set using the Java utility package. And I will show you the other methods now on screen, which you can use if you wanted to, with their descriptions, of course. So that's how you can write code, or how you can use the hash set in Java. So now let's get on to how to code, or how to create a hash map, or how to implement a map in Java. So we're going to be using HashMap, the HashMap utility package. As always, import java u.util.hashmap semicolon. That we're going to be creating our class and our method. And then to initialize our HashMap, we're going to be same structure as from the previous examples of linked list, array list, and hash set. HashMap angled brackets. Now, since it's a map, we're going to be having 2 data types. The first data type is for our unique key, and the second data type for our values. So we're going to have integer, comma, string, and then the name for our hash map. For our example, student ID equals new hash map, angled brackets, and then the data types, and then the open close parenthesis and the semicolon. So now on to adding objects into our hash map. So finally, something different from before. Instead of .add, now we're going to be using .put. Okay, so student ID .put, and then our unique key, which is the integer type, so 1, and then our value for our object, which is a string data type, so quotation marks Eli, and then we're going to repeat that as how many times we like. So .put 2 quotation marks Ellie, and then .put 3 James, .put 4 Mark with a K, and then another .put 4 Mark with a C. Now we have system.out.println, which will print out our whole hash map, unique keys and values. And now we have .get, same as usual, or same from the previous examples. .get will find or access the specific object that we're looking for, but different from the others. Instead of using an index or the unique object itself, we're going to be using the unique key for this. So for example, we're going to be looking for the unique key 2. So student ID .get 2. And now we have our student ID .remove. Same from the others. The .remove method will remove that object inside the parenthesis. For the list, they used index. For our hash set, it used the unique object itself, and for hash map, it's going to be using their unique key. So it's going to be removing the object with the unique key too. So now we're going to be printing out our hash set again, and then now we have a unique, I'll say unique method compared to previous examples. We have our dot values method. So this will return all the values of the map. So for this example, our values is our values are Eli, Ellie, James, Mark, and Mark. So now, if we print that out, it will return Eli, James, and Mark, because we removed because in the code we removed student 2. So now if we run this, it should show that. Give it a moment. So here, so we put in student, let's say this is the student, since this is our student ID. So ID 1 Eli, ID 2 Ellie, ID 3 James, ID 4 Mark with a K, and ID 4 Mark with a C. So because Mark with a C was placed in last, the latest, it will be the one that will retain. And Mark with a K was, since Mark with a K was iterated first, it will not be the one that is retained. So now we have Eli 1 and Ellie, 1 Eli, 2 Ellie, 3 James, and 4 Mark with a C. And because this is a map, we can have two objects that have identical values, because values can be duplicated. Only the unique keys cannot. So here we are. And now we use our .get student ID 2. Student 2 is Ellie. And then we remove 2. And then we remove 2. And then we printed it out again. And then 2 is gone. Now all we have is 1 Eli, 3 James, and 4 Mark. So now we have student ID .values. And then it printed out their values. And the values are the student names, or the Eli, the James, and Mark, as you can see. So that's basically it. And then I will show you now the other methods that you can use for hash map. So I believe that wraps up the crash course for hash map, hash set, array list, and linked list. So, and I'd just like to say that all the extra methods that I showed you guys before, I took them from the website Geeks for Geeks. So if you want to see a more in-depth explanation, you can go to their website. And there's also W3 Schools if you want to use that. So that is all, and hopefully you're able to understand this crash course for the Java Collections framework. And thank you.